Okay, in this lesson we're going to look at recursive sequences and look at how to write the recursive rule. Please take a minute to set up your notebook and then restart the video. A recursive process, a process of choosing a starting term. So it's important we've got to know the starting term, the first term, and repeatedly applying the same process to each term to get the next term in the sequence. Notice it says to use the recursion process, it requires that we know the value of the term immediately before the term you're trying to find out. So we're going to start with the first term and we're going to process it from there. We always have to have our starting value, our a sub 1, and then we need to know what the pattern is. So we need to know the pattern in our sequence. So we're going to look at an arithmetic sequence versus a geometric sequence, and I'm going to start with arithmetic. This is our formula for a recursive equation. We need to know a sub 1, and here is our formula. And then really the only thing we replace here is the d value. Remember, the d value represents our common difference or the pattern that we see in the sequence. Common difference or the pattern. Okay, so to write a recursive rule for this first sequence, let's start out by finding the pattern. What are we doing? Remember, it needs to be an adding or subtracting pattern. We're adding 5 every time. So our recursive rule is a sub 1. Well, what is our first term? Remember, a sub 1 represents our first term. Our first term is 10, so we say a sub 1 equals 10, comma, and then we say a sub n, because we're saying we could find any term, equals a sub n minus 1, and then we write the common difference, plus 5. And that's it. This is our recursive formula or equation. Okay, and the next sequence, another example, looking at the pattern. Remember, if it's arithmetic, it's going to be an adding or subtracting pattern, so it's subtracting 6 this time. Our a sub 1, our first term, is 48. And then we write a sub n equals a sub n minus 1. And then this time we would write minus 6. And that's it. Pretty simple, right? Okay, so now if you're given the recursive rule, how do you write the sequence? Well, we know a sub 1 represents our first term, so we're starting with 6. We know our common difference is plus 6, so all we have to do here is add 6 to the previous term to get the numbers in our sequence. Okay. I want you to look at the next one, and I want you to do this yourself. And you're going to input your answer this on a short Canvas quiz when you're finished. So let's look at geometric sequence. A geometric sequence is exactly the same, except for we have to take into account that instead of having that common difference, that adding or subtracting pattern, instead we have a multiplication pattern, that common ratio that happens between each term. So that's the only difference. Instead of adding or subtracting something, we're going to be multiplying a number. So if we look at our sequence here, this is a geometric sequence, we'll see that the pattern is we're multiplying by 2 every time. So same way, we're going to state our a sub 1, our first term, which is 4. And then our recursive rule is a sub n equals, this time we state our common ratio, which was 2, and it's multiplied by a times n minus 1. And there is our recursive rule. Okay, and the next one, notice our numbers are going down. And I believe if you look at this, you'll find that we're dividing by 4 every time. But remember, our pattern needs to be a multiplication pattern. So this would actually be multiplying by 1/4. So our rule would be a sub 1 equals, what's our first term? 104. And then we write a sub n equals 1/4 times a sub n minus 1. Whoops, and that should be a subscript. Okay. Okay, so same thing with writing our sequences. We know our first term is -3. The next thing we have to identify is what is our common ratio, which is 4. That means we're multiplying by 4 each time. So -12, -48, -192, -768, -3072. Okay? Again, I'd like you to try this last sequence on your own, and you will input your answer in a Canvas quiz.